Alright, well here is video number 3. Video number 3. So if you haven't watched videos number 1 and 2, this is the third video on stellar formation and stellar evolution. This one should be fairly short, I hope. I had only intended to do 2 videos, so here we are, third video. Video 1 I talked about stellar formation and stellar evolution, but really what I talked about was telescopes and how we use telescopes to view stars. Video 2 I talked about stellar nebulas and this top side of the life cycle of a star, the average star. What happens to most stars? Start off in the stellar nebula, they turn into an average star, which then will swell into this red giant. Eventually it will collapse into a white dwarf. Okay. This video that we're on now, I'm going to go over this lower section, which honestly is a little more fun. Okay. If the star material, if the material inside the stellar nebula is abundant enough, if there's enough there, that when the star starts its process of forming, the fusion process, it can still continue to grow if there's enough stuff there. It can become what we call a massive star. And a massive star it is exactly what it sounds like. It's a big star. Really big star. And it goes through the same process. Inward pressure and outward pressure are equal. It's in equilibrium. Totally fine. It can stay here for a while. Not forever, because it's slowly running out of gravity, of mass. It's running out of mass, so the gravity is going to be changing. And instead of going into a red giant, it turns into what we call a red supergiant. Just a bigger red giant. Same process, same everything, just on a bigger scale. But when the star goes to collapse, the collapsing process is the same, okay? The tablecloth out from under the rug. It collapses instantly, really small. But what reaches down here in the middle, when it hits here, there's a chain reaction. There's so much stuff, so much energy that it explodes. Violent explosion. Crazy amounts of energy, so much energy that it's able to fuse the rest of the atoms together. What's left there is then turned into gold and silver and tin and bismuth and I don't know if I said silver, but silver and aluminum and mercury and the other heavy elements. All the other elements from iron up. But it's not done. It explodes. It creates this burst of energy, this burst of radiation, and this burst of the creation of all these new atoms. But it's not done collapsing. The core continues to collapse and collapse and collapse and collapse until you get to either a neutron star. A neutron star is extremely dense. It's not very big. Extremely dense. Or it can continue to collapse and collapse and collapse indefinitely. Just collapse and collapse until you get into a singularity. A new black hole. This is how black holes are formed. Not every star does this. Not every star goes supernova. Not every star turns into a black hole. Only the really, really big ones. Most stars are up on this upper section. Stellar nebula, average star, red giant, planetary nebula, white dwarf. That's how most stars go. But the really big ones are violent deaths. It's pretty cool. So, I don't have any more pictures for you. I don't have any pictures of this. So what I want you to do now is I have a video that I've put on Schoology about the size of things in the universe. Go find that video. Go watch that video. It's about 5 minutes long. Have your minds blown. And when you're done with that video, when you're done watching that, you're done taking the notes, then I want you to go into the pink folder on Schoology and take or open up the Science News Summary number 4. That's your assignment for today. It's due at the end of the day. Okay? I need you to do it. Science News Summary 4. It's just like Science News Summaries number 1 through 3. You go to sciencenews.org. You pick out any assignment or any article that you want. Give me the title, the author, and the published date. Summarize it, and then tell me why you chose it. All right? If you have any questions, you can come see me during seminar. I'll be available during seminar, or feel free to email me. Email me, and I will try to answer you as quick as I can. All right? Have a good day, guys. I hope everything goes well.